welcome to the ARM What is Program series. In each episode, we explore a tech topic to give you insight and perspective into some of today's hottest design trends. I'm Brian Fuller, editor-in-chief at ARM, and today we're going to find out what is confidential computing. And to help us with that, I want to introduce Charles Garcia-Tobin, OS architect and fellow with ARM. Charles has worked in a number of different areas over the years, focusing on interoperation of hardware, firmware, and operating systems. These days, Charles looks after security. When he's not helping us understand what is confidential computing, Charles loves nothing more than taking his camper van out to the beach to enjoy the day walking, swimming, and relaxing. So let's dive right in. So Charles, what exactly is confidential computing?
So confidential computing is about protecting data in use. So protecting data that's actually in memory in use at that time. And we do this by running your programs in a protected execution environment that's hardware-based, where the environment shields the code and data in there from access by more privileged entities like operating system kernels or hypervisors. I like to think of it in terms of rights. If you think about what a kernel has to do, it has to manage the memory that's available to programs. It has to manage what processor cycles are available to programs. But the way we've historically done them is by combining both that right to manage with a right to access. So if I hack a kernel, I can actually access or modify individual programs, such as your email client, for example. Which really makes no sense because actually the kernel's job really is to manage, not to access. So confidential computing fundamentally is about removing the right to access, but retaining the right to manage.
So this is basically a two-part question. Why is this important and how does it fit into a broader strategy around securing digital devices and systems?
Well, I guess the part of the reason why I talked about this historical perspective is because it kind of leads into why is it important. The primary targets for hackers are going to be kernels and hypervisors, because they're the richest target. If I can unlock that key, I can unlock anything that's running. I can access anything that's running on the device. With this rising concerns around privacy, they really want to move to a position where they promise not to access your data, to a position where they cannot actually access your data, so that there's not even the need of a promise, or the promise has teeth.
Can you talk a little bit more about how confidential computing is actually implemented?
Sure. Actually, in the ARM architecture over the years, we provided different sets of solutions that can be used to implement the confidential computing per the definition I gave earlier of hardware-backed secure execution environments. So the earliest thing we did in the architecture was TrustZone, which actually has been in products for well over a decade. And with TrustZone, you can do exactly that. You create a trusted execution environment that cannot be accessed by operating systems, kernels, or hypervisors. After that, we introduce virtualization, which at least can allow you to create a protected execution environment that's protected from a kernel that's running in another virtual machine. And virtualization is actually more flexible than TrustZone, in that TrustZone actually tends to be used to provide fixed use cases that are associated with the firmware of a given device. So, it was very good for mobile, very good for silicon vendors and OEM to provide kind of platform security solutions. Virtualization, but it's not very flexible in that the amount of memory that you can use for TrustZone, for example, tends to be just a carved out thing that you do at boot, and is not a lot, and you can't just magically flick a switch and turn some memory into protected memory on the fly. Virtualization does give you that capability, but you have quite a large set of code that you have to trust. And what we're introducing in ARM v9, the realm management extension, is basically a combination of all of these techniques. So it's kind of all the benefits of the flexibility of virtualization, with, but also a smaller amount of code that you have to trust, and stronger isolation guarantees, which are along the strength of what a TrustZone solution can provide.
So, Charles, is confidential computing something that's in products today? And if not, when can we expect that integration?
So for things that are based on trust and virtualization, these things have been available in the architecture for a long time. And there are products today. ARM architecture supports TrustZone and virtualization, and so it has been doing so for many years. The realm management extension, you're probably not going to see silicon for another 2 to 3 years. We've announced the architecture, so that now frees architecture licensees and ourselves to design CPUs and SMUs and other associated products that will implement this architecture, and then silicon vendors to actually build the hardware.
Well, thanks, Charles. That's some great insight into some amazing security innovation. Now, check out all our other What Is episodes here, and be sure to subscribe to this channel because we'll be adding more as the year progresses. Thanks for listening.